Hello everyone. We are going to present to you our Adbms I, in which we were asked to present a research paper published in the year 1819. The topic that we chose was tampering detection of distributed databases using blockchain. This is written by Kritika Rani and Chinmay Sharma. These are the group members. First is Dikshita, second Kalpesh, third Prachit, and fourth is Rahul. This is the content of the PPT. Starting with the abstract, information stored in different types of databases is always prone to tampering through internal or external sources. There are two major techniques to detect the tampering. First is cryptographic hash functions, second is digital watermarking. However, the above mentioned techniques cannot be used in a distributed database system. This paper explores the idea of using distributed databases to store data and using blockchain technology to detect any malicious tampering. Starting with the background study, in this section we understand the two major techniques of detection of database tampering. First being detection through cryptographic hash functions. It uses internal and external notarizing surfaces. Internal being that using inside the database system itself, external being validation over the network. This includes two phases. First is processing, second is validation. In processing, hash values are generated for each tuple, while in validation, hash values are calculated again and verified with the values with the earlier notarized ones. If there is a conflict between the values obtained from phase 1 and phase 2, then tampering is detected. What is the strategy in this method? Whenever a tuple is modified, DBMS gets a timestamp and it generates a cryptographically strong one-way hash function and obtains a notary ID. Second is, if someone gets access to the database and tampers with it, then the notary ID will not remain consistent with the old one and the tampering will be detected. Third is audit logbook checks for the timestamp of malicious transactions and reverts to the state it was at the time of timestamping. So in a distributed databases, there are a lot of computers accessing the same database. If one computer changes or modifies the database, the second computer can know that the tuple has been tampered with while checking the notary ID. So if the notary ID is different, then the tuple is being tampered. What are the drawbacks of this method? Since databases are regularly modified by legitimate operations, it is difficult and time consuming to distinguish between a malicious tampering and a legitimate SQL operation. And it is necessary to have knowledge about metadata in DBMS. Metadata is data about data. So, unless and until we have the data regarding what is being stored in DBMS, it is difficult for us to use this method. The rest would be explained by Kalpesh and my group members.
Relational databases are widely used in several real-time applications, and hence they need to be secure and protected. So digital watermarking is another technique using which we can deal with database tampering. In digital watermarking, a private key which is only known to the owner is used to embed a watermark on the original database. Later, to verify the authenticity of the database, the suspicious database is taken as input, and then using the private key, the watermark is extracted and compared with the original watermark information. So digital watermarking has two major characteristics as mentioned over here, that is detectability and robustness. Detectability is its ability to detect tampering by examining the watermark from suspicious database, and robustness is its ability to survive unintentional attacks. So both the mentioned techniques, that is the cryptographic hash functions and digital watermarking, work very well with non-distributed databases. But in the case of distributed databases, they do not work very well. And hence the paper explores another alternative to deal with database tampering in the case of distributed databases. So let's have a quick look towards some key features of a distributed database. So as the name suggests, a distributed database is a database which is stored at multiple physical locations. Also, data can be processed simultaneously at multiple points, as a result of which distributed databases can be much faster and also more secure as data is decentralized. So the technique that has been proposed to deal with tampering in distributed databases is blockchain. So we'll understand what blockchain is, we'll understand its structure, and then we'll understand how it can be used to deal with database tampering. So a blockchain is basically a chain of blocks These blocks contain information within them. So the whole idea behind the creation of blockchain was to avoid tampering in digital documents by timestamping. Currently, it is used as a virtual shared ledger for storing history of transactions. A ledger is basically a computer document which stores records. So the fact that once data is recorded in the blockchain, it cannot be altered easily makes blockchain very secure. So let's have a look towards the structure of a blockchain. So this is the structure of blockchain. There are three major components, that is data, hash value, and hash value of the previous block it is connected to. It is a lot similar to linked list. Next we'll understand how blockchain with this structure can be used to detect tampering in databases.
Now let's have a look at the methodology used in the research paper. So as we have seen that there is still a need for more efficient method to detect tampers in database. Blockchain, just as the name implies, blockchain is a chain of blocks and these blocks contain information within it. Originally, the concept of blockchain was created to avoid tampering in digital documents by timestamping them just like a notary service. But nowadays, it is used as a virtual shared ledger used for storing history of transactions like in bitcoins. The main reason behind the popularity of blockchain is that once the data is recorded into the blockchain, it cannot be altered easily. The simple idea behind blockchain is that all the transactions are recorded in blockchain and each block is connected to one before and after it using cryptographic hashes. So every block has three major components and those are data, the hash value and the hash value of the previous block which is connected to the chain. So when the data of any of these blocks is changed by an attacker, it changes the hash value of the block, which makes it an entirely different block which is not connected to the blocks later in the chain and makes these blocks invalid, because of which we can detect which block has been tampered. But nowadays the computers are really fast and are capable of calculating hundreds and thousands of hashes per second, because of which an attacker should be able to tamper with the blocks and recalculate hashes of all the blocks to make them valid again. This problem is dealt in blockchain by the mechanism called as the proof of work, and the fact that blockchain is not stored on single entity but on many entities and each of these entities have a valid copy of blockchain. So whenever a new block is added to the chain, it is added to all the copies of the chain on different entities and after its proof of work is calculated. So what is exactly proof of work? So proof of work is the process in which block's validity is calculated before adding it to a chain, which slows down the creation and addition of blocks to the chain. It means that if a hacker wants to tamper the data, he has to recreate all the invalid blocks, and that too in major part of the entities which store the blockchain, which makes the task next to impossible. Now let's have a look at the advantages used in blockchain. So robustness. Once recorded, data in the blockchain cannot be altered easily, so tampering is very difficult. Decentralization. Blockchains are decentralized structures which do not need any central administration, since they already have their own trust boundaries between the nodes and the proof of authorization. For the safety and security of databases, in this research paper, the blockchain of distributed databases is considered. Now, since the database is a form of a blockchain, it is extremely difficult for an outside attacker to do legit changes in the database. Even if someone is able to tamper some data, it can easily be detected, as this will break the blockchain and change the nonce number.
As we just saw the method of blockchain technology for the security of databases, now let's see how they are implemented with the help of following example. You can see in this diagram there is a distributed database with a lot of nodes, and every node is connected with every other node cryptographically, and basically they trust each other. So there is also a trust boundary around the nodes, and whenever user tries to access a database, whenever he tries to make a transaction into database, he needs to cross this trust boundary, and with the help of access control validation. So whenever a person tries to make a transaction in a wrong way, or we can say whenever a person tries to tamper a database, he has to cross this trust boundary, which is nearly impossible without the access control of the validation. So in the result, we can say that This blockchain basically what it does is it stores the timestamp of all transactions being made into the database. So that's how we get the location of database tampering, because whenever the database tampering happens, from that point onwards the entire chain gets failed and which needs to be recalculated. So this is how we get the database tampering location with the help of this blockchain technology. So now let's move on to the conclusion. In this paper, we actually seen that how to create a blockchain of distributed databases with for the security of databases. So to conclude, we can say that this topic of the database security and forensics is extremely important and vast topic. But there needs to be a lot of research, as we can see there are other techniques such as cryptographic hash functions and watermarking the databases. But whenever we take into the consideration the forensic time and cost, whenever the reduction of these techniques and the optimization comes into the picture, our technique of data blockchain technology gets upper hand, because we can see how easily we can detect the database tampering with the help of blockchain technology, and how it makes impossible for a person to make a false changes in the database and get away with this. Also, there is one more advantage of this technique where we can say we can add it in with the addition of ML and AI techniques. Uh, we can do intention detection of a person who is making a transaction into the database. So we can actually prevent this database tampering even before it happens. So I can say that our new technology of blockchain for security of database in is a very new stage, and but if it's used properly, we can assure that it can lead to the reduction of cyber crimes, frauds, and online breaches to a lot of extent. So